Hey, just a very quick heads up for day 16 and 19. If you want to see the final solution, you can just skip forward to the last video in this playlist. In this VOD cut together, I am not going to get to the final solution. And instead, I'm going to be discussing how I got to the solution off stream in the very last video of this playlist. So if you want to see me struggle, go ahead and watch this VOD. If you just want to see the solution, go to the end of this playlist.
It's looking better. You got to start somewhere, right? And I'm thinking the only idea I've really had for day 19 after thinking about it for 6 days now is that I should probably start with the greedy approach, or rather, just by trying every time we can build a robot to split the timeline into two. One alternative, we build the robot, one alternative, we don't, right? So for every robot we can build at any point in time, we consider both alternatives. What happens if we build it? What happens if we don't build it? And we can probably cut the amount of options a little bit by saying if we don't build robot A, we will not build it until we've built another robot, right? So you have an array of potential robots you could build. For all of them, you check if you can build it or not. If you can, you split the timeline into two. Either you do build it or you remove it from the pool of robots that are available for the next build step. So why don't we do that? I think we are going to have an exponential growth. It's only like 25 minutes that we have to track, and there's not too many robots we can build at any given point in time. But it's still going to really mess up the runtime if it gets very large. The only reason I've struggled so much with this is because I'm 1,000,000% sure that after minute 24, it's not going to be over. Like part two is going to go way further than 24 minutes. Plus, we have all these different blueprints, right? So we don't just have the one. Wait, let me actually remove all of these tabs, go to day 19, and open everything that's in here. So what we have is like a list of 30 different blueprints, right? Ugh. Okay, let's give this a try. Let's clean this code by copying over the template into 19. No, it's called main.py. Okay. Reset y to change. Okay. So we're not going to need this, probably. I'm not sure, actually. And we will have, we need to parse the input. I think I previously figured out how to do this by just replacing colon with nothing. And then doing a splitting by space and then doing maybe int, right? So then this way we're going to get, oops. So I guess we do a list filter none, and yeah, this should work. Okay, so now we got the, wow, okay. First one is irrelevant. Yes, okay. Now we have the cost. Perfect. So let's just parse these in a more legible way. It's going to save us a lot of time later. So we have a class blueprint, which has an init method of cost, or then we have cost clay. I mean, let's call it or cost or Let's just split this one to the side here. So that's read. Okay, so an ore robot costs ore. We have clay cost ore. We have obsidian cost ore, and we have also. I'm trying to figure out my 10-finger typing in a better way. Clay cost for this. And then we have geode cost ore and obsidian. So geode cost ore and geode. Now, for all of these, we can just copy this and say self dot equal. So now we got it all saved and parsed out. Let's say, whoops. Blueprints equals for row in G blueprint of star print blueprint 0. Yes. Let's just very quickly do like a string method here. S plus equals this plus string, because I think it's going to be it, right? And then we probably want semicolon, except for the first one, and then here we just equal. So we have, oops, ore costs ore, clay costs ore, yes. So we've parsed correctly. Awesome. So now we want to try what I just said, splitting our timelines. So we got timelines equals how much stuff do we have? I guess we could say we have a bag. The bag has ore, clay, obsidian, geodes, right? But we also want to keep track of the robots. So let's call this resources. Okay. I think that's right? We have ore, clay, obsidian, and geodes. Ore, clay, obsidian, and geodes. Perfect. And we have robots, which is the exact same thing. We got ore, robots. Yeah. Okay. So in the first timeline, we have, I guess one thing we could do is just specify these as having 0 as the starting value. And that's also true. The robot. Well, I guess we're starting with. Okay, so we're gonna make this easy to remember. Let's start with the timeline of having. Okay, what does a timeline have? A timeline has resources. No, it has a blueprint, resources, and robots. Blueprint equals blueprints, resources, robots equals timelines equals or blueprint in blueprints timeline equals timeline for the blueprint print the resources and the robot or now I think we're gonna have for underscore in range times minutes, right? Or about this actually over here 24. Okay. New time to array for timeline times new timelines plus equal. Next is a reserved verb, so let's call it future. Futures. Timelines. Okay, now we just have to define the futures method. Okay. Self dot resources dot add robots. Robots. Plus equals robots dot. Okay, easy enough. For robots in blueprint potential builds of resources if resources.org greater equals to self or potential is empty potential plus equal or clay costs or potentials plus equals clay if obsidian resources dot ore greater equals obsidian cost ore, and the clay is also in the bank, then we return obsidian. If the geode cost is greater or equal to, and the geode doesn't have clay cost. Is that right? Geode cost ore and obsidian. Yeah, perfect. Now, all of these are wrong because they have to be single array. And here we return the potential. Here, of course, we geode. It's a good thing that I caught that bug before it happened. Now, so the futures is always going to be starting with just doing nothing, which means we just add the resource. So we have a new timeline. But I guess it's just self, huh? It is just self. Futures append self dot build robot. So we now need to build a robot. Which means we return a new timeline, which has the same resource, but we have self dot blueprint resources robots. And here we remove resources dot remove. We remove the robot. So resources remove has a parameter, which is the new robot. And we also need to pass it the blueprint. So let's take this stuff, turn it around. If robot equals or minus equals blueprint or cost or. If clay, then clay cost. If robot equals obsidian, then or minus equals obsidian costs or, and obsidian also costs clay. If equals geode, then we have obsidian and of course return resources of or clay obsidian geo or clay obsidian geo. Amazing. And now we add to the robots the robot. Def add robot If robot equals 4, return robots self or +1, self clay, self obsidian, self view. And then we move you here if it's a clay robot. Here if it's obsidian robot. And we move you here. Okay. Oopsie daisy. Now, I think I forgot to add blueprint as a parameter here. Yes. Resource remove, robot and blueprint. Perfect. I think that's all. What happens if we run this? I mean, we're gonna get some runtime. Oh, robots is not defined. What the hell? Find 1.8. Well, H. What the heck? What the heck? Let's try read. There is more than one main.py. Remember. Thank you. Yep, that's probably because it's self. Thank you. Untype is not iterable. Well, that's probably because we got to return the futures. Blueprint is not defined. Oh, probably because it's self. Oh no! Don't tell me it's running so long. Ooh. She. No way. How far do we get before it gets like super slow? 13. Okay, here's my idea. I said something before that I didn't actually implement, but I wanted to implement. If we choose to not build a robot, then we should skip it for every future timeline, because there's no way if we decide to not build the robot in time point A, but we haven't built something else in time point B since then we decide to build it then now. So this is robots. Nor robots equals a new empty set. self dot ignore robots dot add robot. If robot in self ignore robots, continue. Let's see if this is gonna improve things. Yeah, a little bit. It's still taking very at the rate. Ah, so I think my logic is correct, but just figuring out every single possibility, it's just not feasible in any reasonable runtime. Like, I'm sure we're looking at like gigabytes of memory at this point, 4 or 5 gigabytes at least. Yeah, 16. There you go. It's too much. It's just too much. Do I have a try in here somewhere? Um, I've learned this trick recently that if you do try except, you should always add an exception. Otherwise, Control C doesn't work anymore to finish the program. I feared today's task, and I have no idea how to solve this. This is not gonna help things, man. Like, it's not. Oh, oh. Like, it's gonna improve it a little tiny, teeny bit. Not much at all. I like the memory requirement still the same. Man, I don't know. This one beats me. I don't even know where to start. Like, I don't know how to solve this. I have no idea. I haven't read any hints, nothing for all of the 25 days. Um, I already know that I know how to solve this one. It's just I need to actually implement it, and I need to watch some like refresh my memory on dynamic programming. Like what I know already is that I think it's gonna be possible with dynamic. But 19, I just have no clue. Like I have no idea where to even start. I'm clueless. I really don't know. I don't know. How do you solve this? How do you figure out in what order to build the robots? I guess you have 25 minutes, and if you were to build a string of like things to build, and you just come up with a random order. So the order might be ore, clay, obsidian. I'm gonna call obsidian S. Ore, clay, obsidian, geode, ore, clay, geode, obsidian, geode, something. I don't know. So there's 4 different things you can build, and you might need at most 24 different things to build. So you have 24 to the power of 4. What is 24 to the power of 4? That's not too bad. So I could pre-compute the timelines. So, and you cut all of them out pretty fast. Like, not for all of them, you have to go to 24 minutes because, I mean, you kind of have to, but And the thing is, like, even if we move to like 1,000 steps, okay, maybe 1,000 is too much, but 100, we could do 100 steps. That's probably going to be the second task. Then again, like if it's going to go all the way up to 1,000 or higher, then we're fucked. But this might be a solution for part one at least. I mean, I thought this was going to be a solution for part one, but it's not. So failed attempt at part one. You know what I'm gonna do? I'm gonna get some coffee at 6:12. I think I gotta go here at about 7. So if I go get coffee 5 minutes and then build this, I should still be out by 7. Okay, that's the plan, and I'll be back in about 5 minutes. Merry Christmas. The more I think about this, the more I think we got this because we can cut out so many options if we already figured out the prefix and the result that we got out of it. So we just store all the prefixes of the last timeline that we figured out. And then if we hit another thing that has the same prefix, we know that we just weren't able to get to the rest of the letters. So it doesn't matter what was behind the last robot we built because we just weren't able to build any more. I think that's a great idea. I'm very happy I came up with this. So let's see, how do we have to change this? Well, first of all, I got to figure out all the permutations. So I think we have Python all possible choices with repetition. Exactly. Yep. I think that's what we need. I'm pretty sure we already got itertools. Import it. Get rid of all of this crap. And print this. Now. So we got, let's call them ore, clay, obsidian, and geode. And then let's repeat them by like, I don't know, 5 times. What are the... We didn't import itertools. What the heck? Oh, we just imported products directly. What the heck? Okay. So my theory is that the length of this, if we do this, times 24 is going to be 32K. What a breeze. Or not. Huh. Well, that's interesting. How about we don't do this, and we instead do this. Wait, but it's 4 different ones. Isn't it 4 to the power of 24? Oh, I'm an idiot. Why did I think it was going to be 24 to the power of 4? It's 4 to the power of 24. Of course it is. Shit. Hmm. Well, let's give it a try anyway. So, God damn it. For sequence in this sequence equals empty string. Sequence. blueprint, sequence, return. All O's because we start with all or. Perfect. Now, we can skip forward a little bit. By excluding all the ones where there is no G. If G not in sequence, continue. But even calculating the length of this took ages. Ages. Shit. This isn't going to work. This is not going to work. How much building are we doing here? We are building 8 different robots. So how about we just say we repeat this by 12? What's 12 to the power of 4? Not too many. No, again, it's 4 to the power of 12. Why am I so stupid? Still not too many. Okay, so for blueprint in blueprints, who needs X? Timeline equals timeline of blueprint resources 1 and robots. No, I think we start with the resource. Yes. Okay. So how about we set n to 24? We say n divided by 2. And then we say 4 underscore in range 24. N timeline dot step. Max G equals 0. Max G equals max max G and timeline resources geodes. Print max G. And we got prefixes. So interesting. Anyway, prefixes, add timeline, current prefix. So we do have to replace all of these by O, all of these by C, all of these by B, and all of these by, oops, this is of course B, and all of these by G. Now I do have BB here now because I did an oopsie, but yeah. Cool. So now we have to figure out how to cut off the prefixes. Oof. How do we figure out the prefixes if the prefixes can have different lengths? Well, I guess we get all of the potential prefixes for P and potential prefixes of sequence. Why did I remove the join? What happened there? Oh, but there. If pre in prefixes break found equals false. True. If found continue. Def potential prefixes of string return s until I or I in range of n. Let's just give it an n as well. So I don't have to do length every single. Now, I think I want to start with 1 because it doesn't make sense if we don't get at least one value in there. And I don't want to get the last character, so we're set. Okay. So let us remove this crap. If not, can build self robot order 0 continue return. If not, self robot order also return. So we get a timeline which has the robot order. It's the sequence. Robot order. Self robot order equals robot order. So let's call this step. What equals this? Robot. Oof. Self current prefix is empty string. Self robot order equals self robot order. Okay, so potential futures is now can build. So that's an option of blueprint with resource and timeline. We don't actually need the timeline here anymore because we are not checking for ignore robots. We're not ignoring anything anymore. Okay. Cool. So can build is a blueprint method. Self blueprint can build robot. So can build robot. Now, return false. No, I think there is a better way of tackling this. So if robot equals letter, return this. What these do have to go. That's true. And it indented itself correctly. So if my theory is correct, then this should work. ASER, resources not defined. What do you mean by that? Right. Well, maybe it's resource. Init is missing one argument, robot order. Is that so? Ah, we have to change. So this is now going to be mutating, which means we simply do self dot start. And we do the same for adding down there. It's factory. Ugh. Self or equals 1, self clay plus equals 1, self obsidian plus equals 1, geo plus equals. Well, the good part is that this is really resource saving. We're not going to take up a lot of memory here. Come on, how long is this taking? It's 4 to the power of 12, for God's sake. That's only 16 million. And we're saving all these prefixes here. I mean, saving all here. So only give me a blueprint one. How about that? Does this work at least? Please tell me. Oh, and this is not gonna help much. Oh no, it's still taking way. I hate this so much. We're not getting stuck in an endless loop, are we? Like if I do divided by 10, is it still gonna run forever? No. So let's see. 4 is probably gonna be over like this. Then 5, also over like this. 6, also over like this. 7, bit longer. 8, 120. Not too bad. 9, 126. Well, maybe. No, that's not true. Please tell me it's not increasing anymore. 126. Come on, give me 126. 26, please. Damn it. This is not even feasible. In 24 minutes, you cannot possibly generate that much stuff. It's just not possible. Okay, let's get the example from the input. I will have to run in like 10 minutes. So I will, again, not solve this, which is very amazing. I'm very happy about this. Couldn't be better. Get all of these new lines, faces. Let's get these new lines, faces, this one. You now have 9 open geodes. And in the meantime, my program tells me we have 135. Oh, baby. So what's wrong? Tell me. This doesn't seem to be super wrong. So what's happening? Why is this so ridiculously high? I don't get it. Does this not work? I don't know. I think I'll I'll have to call it and work on this another time. I'm not even sure if it's the right approach at all. I don't know what's wrong with my code right now because clearly we're getting wrong results, which is also amazing. Yeah, full stop. I have a feeling that can build is it is. This is supposed to be obsidian. Nine is the answer we're looking for, right? Nine. Can we get nine, please? 18. Shit. Well, last chance I can think of. Let's go -1. I still think it's not gonna go to 9. Down to 9. Maybe. I don't know actually. Nope. So we're still wrong somewhere. Let's figure that out. Um, oh baby. I have one last thing. The order here is slightly wrong. So hand build is this and this. So now we can say can build, not can build. Because we're not using the resources that we're getting to determine if we can build. That's a big. Yeah, you're not wrong. Let's just never store this variable. Maybe it's going to go down to 9 now. I think we are starting to have a better understanding of how this is supposed to work. And I really got to jump and gotta go. Let's see. 7, which sounds a lot like we have to remove this again. And now we definitely know we don't have to do higher than 8. Okay, so that's pretty cool. Now, we don't know if there's ever more than 8 robots to be built. That's something that we still have to figure out. Um, I'm also not sure if this really speeds things up. Like the whole prefix thing. Doesn't really seem to speed things up. I mean, maybe if we go up to 9, it might help. But I also don't. 3.866 total. No, it makes things worse. So let's not bother. Prefix stuff. Okay. So, I mean, in theory, um, this should give us, like, what's the 12? Yeah. So in Blueprint 2, we are able to get more if we build more, right? Ugh. God damn it. Still 9. Oh my goodness. Like, how many robots do we have to build with this one? Probably 12. That's probably as high as it goes. So my n divided by 2 wasn't really wrong. Unfortunately, it's just a very, very big number. Ugh. I don't know. Like, it's gonna take 2 minutes to run this because the previous one was 31 seconds. Now it's 4 times many. I I hate this puzzle. Like, I really hate it. I I have no idea how to solve this in an efficient manner. Like, even just the first part of it, I have not even the faintest idea of how to get there. Maybe I'm missing the obvious here, but I've really been thinking about this for a couple of days, and I can't come up with an answer. I mean, obviously, we have to produce a ton of different Obsidian robots, right? So maybe the answer is just build an Obsidian robot whenever you can, and otherwise try to optimize the. See, this I don't believe. Like, What if we just had the blueprint 1? So this is still going to take a minute to compute, but if this is still 9, then I'm shocked. I'll be back in a minute. I'm going to throw away my cup. So, even if we give this like ages to compute, we're just not getting there. And it definitely parsed correctly. Like we printed out here, there it is. It's different. I don't know. I'll have to think about this. I think something about the ratio of clay and ore for obsidian, and then just always building obsidian if it's possible, and of course always building geode robots if possible. Has to be that has to be where it's at. I don't know. Let's study some more the example and how it's done there and get back to this. I don't know. For some reason, I'm having so much trouble with this particular day. I didn't see this. I'm sorry. I don't know how long the comment has been here. Thanks for giving this comment. Um, and you're right. There is also the opportunity to deliberately not build a robot. But I think what I'm saying with my approach with the different strategies is that you have a sequence of robots which you're going to build no matter what. So you're always going to build the next robot in the sequence as soon as it's possible. And if this robot is possible to build, you never want to wait longer, right? So let's say your rule book is you always start with you always start with an ore robot, then you build a clay robot, and then an obsidian robot. That would mean that as soon as it's possible, you're building the ore robot. Then as soon as it's possible, you're building the clay robot. And then as soon as it's possible, you're building the obsidian one, right? So there's always going to be an order of robots which you build as soon as they're available. And that's what I've been trying to do. And I've had a math error in my head. So I didn't do n to the power of m, but the other way around. So it seemed feasible, but it's completely off. Yeah, it's unfortunate. I mean, I've been able to solve everything every other day in Advent of Code history up until this day. There's only one part missing, which is the dynamic programming part for day 16. But if you look at events, like I'm all the way up to 396 stars, right? So one of them I'm going to get for free. One of them is going to be dynamic programming. And then there's only 2 left for 400. And that's exactly the ones I'm trying to get right now. And I have no idea how to get there, which is frustrating. Thank you. Thank you. I mean, 400 coding puzzles over the course of like 8 years, right? And I've been able to solve all of them at some point, except for this stupid robot building. Like, it's the only puzzle I haven't been able to solve yet. Yeah. This is what my map looks like now. my calendar, you can see it's almost fully filled out. There's still a little bit of gray in here. This row being completely empty and having no stars is what we've been trying to solve for the last hour or two. Anyway, gotta go have dinner. Christmas things, of course, because it's Christmas Day. Thanks for the comment, Bijective Proof. I'm sorry I didn't see this earlier. I should really start setting up my chat for being able to see it while coding, like on my phone or something. Yeah. Merry Christmas, and we'll hopefully crack day 19 soon. Bijective Proof, if you're ever seeing this as a VOD, hit me up on Twitter or something. Let's chat. Oh, yes, now you're seeing it. Well, anyway, all I was trying to say is you're definitely right that you can pause to build something, but let me know if I'm wrong about assuming that if you know what robot you're going to build next, then it doesn't, like, you never want to wait on it. If your rulebook is the next robot I'm going to build is Obsidian, you're just going to wait for Obsidian to be available, right? So that's the logic I've been trying to code, so that there's always going to be, I mean, let me commit this. So I just committed it it's not working just yet. So if you go to the GitHub link that's in the bio, then you can see what logic I've been trying to come up with. I think you never want to wait on building a robot if this robot is definitely going to be the next kind of robot you want to build. Yeah. Let me know if I'm wrong. You got my Twitter. And thanks so much for the comments. Have a very Merry Christmas. Spend some time with your families if they're still around. And I'll see you when I'm trying to solve this next. Have a great day. Have a good weekend. Hello, and Merry Christmas yet again. I got about 30 minutes, and I really want to understand day 19 of Advent of Code 2022 a little bit better. I have a few ideas. I'm not overly confident in any of them, and I will give them a try by first looking at the order in which we are building stuff in this example here. So let's see what we are starting to build. So if we take a look at this order, yeah, and we remove all of this. We never built any ore robots. It's crazy to me. So we do clay, 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 obsidian, clay, obsidian, geode, geode. That's not what I expected. I thought it's gonna be or clay, 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 obsidian, 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 geode, geode, geode. So this is already a bit of a problem. Now let's look at the ratio. So in the perfect world, we have 4 clay robots for every ore robot. Um, yeah. Hmm, 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 hmm. I don't know. I feel like you have to analyze somehow what the total cost is going to be for the number of geodes that you can build. Number of geodes you can build is always going to be somewhere between 1 and 25. And for each of those numbers, you could figure out what is the exact requirement of materials um, to get there. Now, probably most of these blueprints will require you to build as many obsidian robots as possible. So an obsidian robot has a ratio between ore and clay that's necessary to build it. And you could try to always say like 14 divided by 3 is 4 and something. So you always want to have 4 times as many clay robots as ore robots. So what you could say is um, if you can build a geode robot, always build the geode robot. If you can build the obsidian robot, always build the obsidian robot. And otherwise, try to increase the number of the other two robots while keeping the ratio in mind. So as long as you're smaller than the integer part of this ratio, you build a clay robot. Otherwise, you build a stone robot. So let's see. I think I want to try to remove all of this stuff, remove all of this, and not charge my phone. Oh. So let's screw this and this and this and this. And this. And this. And this. Equals self next robot. Def next robot self return or we're just building or until the day ends or clay actually. So we have to remove all of this stuff. This is now next robot. Oops. Let's just replace this. Do we have any more what orders? Nope. Okay. I think that we have all the changes made. I don't think we need anything else here anymore. Like the rest is fine. So how about we get the string method into the resources and just do a print once we're done with all. So we can figure out what would be the maximum amount of clay robots we could build. Def string self return format string of self or format string of self clay, and then we got obsidian and okay. I kind of feel like I'm very tempted to rename obsidian to something else that starts with a B because I named my ore B for obsidian. Maybe we should call it. Why don't we call it gold? That's going to make things a tiny bit more easy. Goldidian, yeah. This one doesn't matter because we remove all of this stuff anyway. And then we can turn all of these into G. Oh no. I'm such an idiot. Of course, um, gold also starts with a G. So let's call it silver. That should finally do the trick. Okay. And silveridian is just obsidian. Okay. Right. So we got ore, clay, silver, and gold, or geodes, whatever. We were just about to finalize this printout here. We got silver and geodes. Okay. And now I just want to print timeline resources. This probably has at least one issue in it, or not. Well, we don't need to print the blueprint anymore. We already figured out that this works. Yeah, I mean, it appears that we're building a lot of clay robots, so that's a good thing, I guess. So, if self blueprint can build self resources, gold, return gold. If can build silver, return silver. Now the desired ratio is self, blueprint, obsidian, no, silver, wait, no. Silver costs clay divided by silver costs 4. What did I just say? We have 14 and 3, so this is going to be 4. And now if self robots clay is smaller than self robots or times desired ratio, return C, otherwise we return. Let's see what happens now. We managed to open 4 geodes. Well, this is gonna go. Let's print whatever we're building. Next robot. Remove all the prefix stuff. I don't think there's any more mention in this. Yes, okay. So we should be building. Oh, yeah, we might deliberately choose to not build this one, which would improve things. Why would I choose to not build the ore robot? Because the ore robot costs 4 and we're removing 3. This is tough. This is tough. Like, if I just return G here, I'm pretty sure it doesn't make it better. Because we still build way too many. So we look into the future and we say, if we can build an obsidian robot, a silver robot, this many steps into the future, we don't do anything. Hmm. Um, look ahead on self dot look ahead equals. We wrote this method before, which is kind of frustrating. Um, return resources plus equals but plus future equals resources, future add future equals future robots or underscore in look ahead. Self resources equals self resources robots. Oh, I probably need it. Okay. 8, which is pretty dang good. Um, Now I do want to see if it gets better if we have a lookout of 2. Yes. Okay. So we get all the way up to 9, but if we do a lookout of 3 or 4, it's probably going to start going down again. Yes. Okay. So for look ahead in 0, 1, 2, 3, 4, 5. And then we do look ahead. If this is greater than max g, then print look ahead this and max g this. Okay. Do we have a larger example than this? I don't think so. This needs to go. What happens if we run this now? Okay, let's remove the build printout. That's kind of where it goes. So the look aheads that have one out were 0, 1, 2. Wait, wait, wait. Why do we only do one blueprint? Oh no. Oh, Rob. We're only getting to 4? How's that possible? Ugh. I hate that they chose an example that's so easy to get to, and then the second blueprint here is so damn difficult to get to. Like, why? You know what I mean? Damn. I got about 10 minutes. I'm not going to make any progress here in that time. Oh, this is frustrating. This is not improving things. I don't think anything more than 5 is reasonable. What I don't understand here is why the hell, like, are we building? Oh, because we're done, huh? Interesting. You're able to get to 12? What are you talking about? Hmm. Maybe I should add the geode costs. I don't think it's gonna help stuff. Cost, geode, 4. We are getting to 5 now. but 5 is a long way away from 12, you know? All geodes. Man. Well, gotta leave in 5 minutes. Okay, what I'm not understanding is why we're never building this orb robot here. If look ahead is 0, then this should work. Maybe there's an error in my code. Ten is a lot better. We're almost there. Now we have too many for robots. So maybe we remove this one again and just say solar cost or still at 10. Still at 10. The one where we end up with 10. Why are we building this S here? Doesn't seem like a great idea. I mean, look ahead is at 0. I kind of feel like we gotta look further into the future for the G's. But we still, man. It's so crazy that we're stuck at 10, huh? Gotta go. Um, Progress, maybe. Doesn't really feel like progress. We're doing something. I will return to this. I'm not sure I will ever solve this without getting a hint. I think we might need a genetic algorithm here to improve our strat strategy, but I'm not sure what parameters we are even looking at. We could do machine learning. We could put in all the resources we have in the blueprint and then get out the right thing to build. But I don't think that's really feasible. Man, it's crazy to me how many people have been able to solve this day. Like, nothing I'm doing seems to be working yet. If you look at stats for day 19, 13,000 people have been able to solve this. Did they all cheat? Did they all read hints? I don't know. Then again, only 8,000 people have the second star here. So, yeah, but only 5,000 have the first one. Like, this one was super easy to do. Like, why, why do 13,000 people have both stars here? That's crazy. Well, I don't. I hope I'll be there soon. And I'll keep thinking about this. Man, I don't know. I feel like finding parameters which are easy, like which have a smaller space to iterate through, just like we did with the look ahead now, that's the way to go. Only I don't know which parameters to look for because other than look ahead, I can't think of anything. Fun, fun, fun. Yeah, I'll be back soon, and I hope you have a great rest of your Monday. Bye bye. I just realized that my VODs are all gone. I thought I had more time to download them, but I don't. So everything before day 20 is gone. I only uploaded to my YouTube um, day 12 onward, right? Yeah, 12, which means that we are losing day 13 to 19, but it's not a big problem. This was just a little experiment to do first live streams, and I'll make sure to download the VODs quicker next time, next year if I'm going to do this again. Who knows? I was just starting this because I had an idea of how to solve day 19. Mm. Basically, I rolled back my last approach because it didn't seem to be working with the heuristic. And now I've just renamed Obsidian to Silver again. Rename Obsidian. Because I really like the silver and gold analogy, just makes it easier to remember and gives it a unique letter. So we got OCSG. And now I think that we want to remove G. This is my genius approach. So if O, C, or S is not in the sequence, then we continue. We don't need the entire prefix stuff, I don't think. We committed it, so we can always get back to it later. Prefix, yes, yes. Okay, no more prefixes, which is great. And now I think the main difference that I want to do, I mean, first of all, I did discover a bug, I think, last time, which is, I think, only in the new code that I wrote, and I don't think it's in here. So this was performing correctly, I'm pretty sure. It just never, whoops, this is a VOD. Nice. That's it black. Anyway. So my big idea is to always build geodes when we can. Um, So let's say if not self-robot order turn, what was this? Yeah, next robot equals robot order first. Second VOD that I just downloaded because it's going to get deleted very soon. Um, Now we set this one to next robot. If not self, no, I think it's blueprint. Yeah, no, self can build next robot. No, it's definitely the blueprint, right? Can build is in the blueprint, yes. And the parameters are resources and robot. If not, self blueprint can build resources and next robot. Return. And now here we say if can build G, then next robot equals G. And then else all of this stuff. Because it doesn't matter if we cannot build, if we don't have a robot order anymore, if we can build G, right? Yeah. And this doesn't matter because it's, even if it's empty, it's just going to continue trying to do that. Okay. So what happens if we run this? AOCR, AOCA, CD22 at 19, AOCR. 0. Amazing. That's not what I wanted at all. Okay. This is not going to work because can build isn't even defined. Dude, what is happening? Ah, uh, maybe we want to return this. So my theory is that we're going to get 12, the correct answer. Let's see if my theory is correct. Ooh, like really close. I Fortunately, I don't really think that it's going to get much better if we increase the timeline. You can already see how much longer, like this is taking 3 times as long as the previous execution, and that already took a couple of seconds. So I think this is just not going to happen. I wonder if doing this in C++ would improve things. I mean, of course it would be so much faster, but um, yeah, it's probably not the choice of programming language that's screwing me up here. If we remove this, which is kind of stupid to do because you have to run through the entire sequence a lot, does it get faster? No, not really. We had this whole prefix thing, right? And we already know that we are not going to get to the end of most of these. So if this is greater than max g, then max g equals this, and we print timeline dot resource. Oh, come on. Didn't I write a print string method for this? It's 100% in there. Yeah, here it is. Huh, there we go. I'm getting so close. Like, if I could only figure out how many to skip, because I've already gone through that prefix, that would be so helpful. But calculating all these prefixes is so damn inefficient. So I'm not really sure how to calculate this. Let's get smart about it. How do we figure out if we want to skip? Oh man, how do you skip the prefix that you've already tried? Because we never get to the entire end of the string, or very rarely. Um, I want to try something. I want to see if self resources um, and off equal because I want to print it. It's so fascinating. All of these ran out of stuff to like the sequence. We have to make the sequence longer here. What is the sequence? Okay, I mean, sounds a lot like uh, I just have to figure out how many to build of each. So let's commit this as new insights so that we have it in the bank for later. And let's try something like this. Um, so we got OCS for I in range of n, which would go uh, yeah, sure. For j in range of I plus 1, and then for k in range, return. This has to be j. Um, let's just print I think, and let's set it to like 6. Oops, reset this. Okay, so let's AOCR. So we got 1, 2, 3, 1, 2, 4, 1, 2, 5. Um, okay, let's try something. I want to go from 1 to n minus I minus 1, right? And here I want to go from n minus I. So we have, I mean, what are the ways to split 6 different ones? We got
A, B, C. We got A, B, C. We got A, B, C. We got. I think this is right. Yeah. Okay. So the sum is always going to be. No, this stuff doesn't work. Okay, I think what I had before was better. Um, S equals MT for KL in range of N if L or I S is equal to A. Or actually, we can do the real letters now. Or clay, silver. Well, I guess we don't even need this one. We just need those two ranges, right? Because the third one is going to be like you only have two splitting points. Um, yes. So if L smaller equals I, smaller equals J, and otherwise it's S. Friend. Okay. This is too long. Ah, can you? Okay. It's still kind of long. Didn't I set it to be 6? Apparently I did not. Okay. So apparently this has to start at 0 because otherwise, yeah. Um, and this has to go to -1. Yeah, I think this is correct. These are all the ways to arrange them. That's what I wrote here, right? I just started the other way around. Yeah, looking good. Okay. Um, so here we do run sequence. And we should probably do global maxg. Okay. Now what do we remove here? Um, wait, what? What the heck? This can't be right. Oh, yeah, yeah. Okay. Um, this is what I'm talking. Uh, yes, 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 yes. Okay. So run sequence or sequence has a global uh, and blueprints. Do we store anything else? No. Let's not do this. Let's also do this. And let's say, and then n equals blueprints. Now we copy in this
Um, well, I guess we give it the blueprint as a parameter because I want to do that in the outer loop. That's correct. So blueprint, only blueprints for in range n timeline step if greater equals yes. Okay, let's see what happens here. Wow. Holy cow. Okay, I know the answer. This is so stupid. Why is this the answer? Uh, my goodness. 12. 12. Not correct. Okay. Almost, maybe. But not quite. It's a little bit infuriating because now we get the right result for both, I think. Um, yeah, I mean, we can do this. Oh, interesting. We only get 8 for the first one. Huh. So I guess there's two different algorithms, which kind of interesting, which kind of compete. Wait, let's check out 19 MD again. So 9 is the best one we can do for the first one. 12 is the best we can do for the second one. Um, I kind of want to run both. So now we have second blueprint optimal. So this is interesting because for the life of me, I wasn't able to crack the second blueprint and get the right result. And now we have the right result for the second blueprint, but not for the first one anymore. So what I'm thinking is maybe we combine the two. Um, so we got run sequence. And we also have like simple approach or blueprint. And the simple approach blueprint will do something else. If I recall correctly, then I mean we should rename this to be like step sequence. We kind of want to combine them now. So here we wrote this method. I think what I'm actually going to do is open this on GitHub on the internet because then I can copy out the code easily. So let's go to GitHub /yscreens code. Then we have 2020, 19, main embed pi, and we go back to version progress maybe. and we browse the file. Dude, I hate this. Why doesn't it go to the file directly? Ah! Okay. Um, yes. I think these two methods are what we want. I think this is all just renaming stuff. We didn't really change much here. So if I take these two methods and I put them here and I name it, what's your issue, huh? Unindented by one? No, still an issue. Okay. And then name this one step heuristic. Then I think it should work. So we set the look ahead to be, I mean, look ahead 2 is just look ahead now. I think the look ahead was, let's define the look ahead and then do t equals timeline, print yada yada yada. Instead we do step heuristic. We don't have a sequence anymore, so that's gray. Okay, so what we could do is for L ahead in 0, 1, 2. I don't think we need more. Maybe 3, but that's going to be look ahead. Okay, I think now we have both approaches. And of course, timeline has no attribute look ahead. So how about we say sequence equals sequence and look ahead equals look ahead. And then we define both parameters as optional and call this one sequence equals none and oops, nope, equals none and look ahead equals 0 is empty if sequence is none. Sequence, we have to do this because of the permutable default value, of course, and the look ahead equals the look ahead. Okay, now it should work. None type has no attribute or. Well, that makes sense. I think we changed if dude, what the heck? Why can't I go to this line? Stuff. Okay, let's go to line 84. So can build has been executed with none in line future 2. Interesting. That's because this doesn't return the future. So we should have an add and an add mutating because this method is used down here and this one is not resources. So add mutating is on the resource and on here. This one is only used here. Is that right? No, it's also used up here, which is where we define it. Uh-huh. So here we can say mute. Okay. So how do we write the one that's not mutating? Well, that's simple. We just go over here and we copy it out. Resources, add a method add. So we just do this. Cool. Okay. Now there's a lot of printouts that I didn't remove last time. Here we don't want to do this. This. Okay, now we got 9 and 12. Now, I'm extremely unsure if this is now going to work because just because we optimize one of the two, ah, stupid. Um, and then the other one doesn't mean that we have all potential scenarios figured out. Oh, I didn't even read the prompt correctly. Okay. So, um, the answer is 0, and the answer plus equals num equals 1. Yeah, but I'm gonna anyways because I can never remember how to do enumerated in Python. Num times g. So let's see if we get the right result here. Running print the answer at the very end. 33 is correct. So now let's see if we get the right answer for our real thing. Too low. Well, so now we figured out how to solve the first one, and we figured out how to solve the second blueprint with very fast methods. But none of them are sufficient in order to solve the real input. Now I did remove the number start here, but as you can see, it's always going to be sequence. So that's not. I wonder if we had a look ahead of +1. This was going to change something. No, 1120. God damn it. I think we figured out that looking ahead further than 4 was never a good idea. Nope. In fact, now that we have the +1, this is probably sufficient. Yes. Well, I had two very good ideas, um, which both didn't work, but both do work for the examples. So now I'm out of options. I don't think I will ever solve this one. We have one approach working for the first test input. We have one approach working for the second. C33, we get the result, but none of them work for both. I mean, what's the sequence here? There is a chance that building a geode robot every time you can is a mistake. There's a chance. Um, I don't think so, honestly, but so we have slide adjustments, which also didn't work. So now I want to, of course, add a period to the end of that commit message. And try one last thing. Let's remove the simple approach completely. Let's print max G and see what we get here. Oops. Uh, okay, so this 8 is a problem, right? We want to have it be a 9. And I have one last idea how we might be able to have both work with the same approach, which would be indenting all of this by 1, giving it a K, which is a J plus 1 till n minus 1. And now we add gold to the mix. So if it's smaller equals than K, now, of course, we want to remove the special treatment for gold, which is so if we remove the special treatment for gold, then we get nothing. We get one less. Like it doesn't help at all. I wonder why. I mean, let's revert this. Clearly, building geodes whenever possible is the right approach. Um, well, yeah. So we get 9 and we get 8 and 12. So how do we fix the 8? Well, maybe there's an option to do a switch. Well, first of all, how far do we actually get into the sequence? Um, what if we say, I don't know, n equals, yeah, like times 3 divided by 4 or something. We still get the right result. Perfect. Okay. So let's assume that holds true. And let's um, do a new method called run sequences, uh, which for I in range of 3 and j in range of 3, it will do run sequence. And I think we want to give this I and j as parameters, but we'll call them I underscore and j. So what I'm thinking is we want to add, like we want to turn A, B, 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 C, 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 C into adding 2 B's here, adding 2 C's here, you know? And how many we add, that's the new I underscore J underscore. Um, so we say S equals S. And then for X in range of uh, N, no, I underscore S of I minus 2 minus X is equal to play minus J is equal to silver. So if just for a second we don't do this and instead we print s underscore and we do um, run sequences n equals 6. Do we even need n for this? I don't think so. If I minus 2 minus 2 smaller than 0, then break. No, is greater equals 0, then we do. And if j, then we do that. Okay. I don't think we have an n. Okay, so let's say the sequence is A, B, 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 C, C, C. But actually it's 4 times O, 4 times C, 4 times silver. And then I would be 4, I think, and this would be. Let's see what's gonna happen. And I just want to cause an exception here. Blueprint is not defined. Yeah, this is not working whatsoever. Oh, interesting. Interesting. Okay. So I think it's working. Like we're adding a C or 2 C's in front, and we're adding an S or 2 S's in front. Yeah, full stop. I don't know. Let's try this. Nope. We still get the same result. Which is weird because shouldn't. Wait, are we never building any ore robots for this one? Fascinating. So maybe we don't need to build ore. We always need to build clay and silver robots. So um, I guess this doesn't have to be I+1. I'm confused. Shouldn't there be like let's let's print this, huh? Like what are the ones we start with? Head minus 12, 20. Sure. Yes. Okay. Okay, wait, I'm confused. I'm very confused. I'm extremely confused. I don't think this is right. I think this should be smaller. I'm still extremely confused. Look, we only need 8. N can be 8. So let's print all of them. There shouldn't be so many. TMP Okay, so we should have the sequence CCCSCS. Look, it's even just 6. The sequence is, the length is 6. CCC. What did I say? CCC SCS. CCC SC. See, this is what I don't get. Why this? Like, I guess it's not -2. It's actually minus, maybe. I don't know. So do we now have CCC SCS? Yes, we do. So we have the perfect output, right? Let's remove this print. Let's get this back in order. And let's run it. How is it still 8? That doesn't make any dang sense. I guess we do have to put G in there, right? So for k in this exact range, except this is now a j, um, this is now gold, this is now silver, this is now k. Okay, that's better, but I'm still not very happy with this whole approach. And I do have a feeling that this is not going to be the right answer. It's super hacky, it's super repetitive. Um, yeah, I have nothing more to add. 1150. What did I have for the answer before? 11, yeah, 1140. Well, I tried. At flipping because we're flipping the order of two of these. Wow. I don't know. I've tried every single thing I could think of for the A19 now, and I just can't really come up with any other ideas. So I think this is it for now. Ooh, that was close. Hello. Hmm. I have to fix the screen capture. Ah, this is how you fix it. Okay, you can just enable and disable the cursor. I have another idea for today's puzzle. First of all, let's commit this. Not quite. And I want to try something. So, in order to try this, first we have to make our code a lot more stupid. Let's remove the special case here. Let's remove this special case and add geodes to the mix. Actually, we can make this a little shorter. Okay. And also, I think we don't even need this anymore. So let's not. Okay. You know what? I'm gonna go back to the very stupid old thing I did. So for next robot, this. Don't need time, I don't think. I don't need the next robot. I don't want to ban anything. I'm gonna make this a lot simpler, which feels good. Um, so any mention of time should get removed. Do we have any more time as a full word? Yes. Well, then again, I don't think I need to do this either. So let's just come. So the next robot should never have self in front of it. Yes. Next robot, next robot. Let's not do this. I think we should be good to go. We don't need this anymore. This. This. Let's do this. This anymore. Let's just remove it, huh? While we're in the process of simplifying this. Okay. So um, next buildable is equal to empty if self blueprint can build the next robot, then next buildable and next. Then we add the resources and then we say for futures self for robots and buildable futures append this stuff. Return. Okay. Let's rename buildable because apparently it's not a word. Why can't I do Command D? I guess because of. Okay. Command D. Next possible. Right. And build is gonna copy. So we do have more mentions of next robot. I guess no, this is actually the cool. Okay. So I think we're at a pretty good starting point now. Except all these two tuple methods we don't need. So let's cut these out. We don't have it, right? Yes. Okay. So now we're at a very good baseline. Now I have one more idea. Back to the roots. And this idea is the following. After we determine all the possible timelines, we filter them. For timeline in new timelines, or other in new timelines, if other equal timeline continue. If timeline dot inferior to other, then we say inferior is false. Here we say inferior is true. And now we can say break if not inferior timelines dot append timeline. So what am I doing? I'm trying to filter the timelines by the ones which are actually good. So if there's one where we're just inferior to in any measurable way, we don't have to continue looking at this one anymore. Now we just have to write this method, which is def inferior to self other. Better equals self dot resources dot better than other resources or self robots better than other robots. Return not better. And this we determine by better than self other return self or greater than other or self clay greater than other clay or self silver greater than other silver or self geode greater than other geode. And the same method can be applied to the source. Okay. I think this should make things faster. Nope. Hmm. What is happening? Great question. So we have 121 possible robots. That's a lot. Print timelines. We've been here before. Let's print the resources. Let's see what's happening here. Hmm. Something about future is clearly wrong. Um, ah, this is it. Shouldn't mix and match variable name. Cool. So we should get 9 and 12. We're not getting anything. So I'd kind of feared that this might happen because we now have a quadratic runtime for the number of timelines that we're looking at. I was hoping that we are cutting out so many possibilities this way that we don't even really have to worry about it. But clearly that's not. I've had one more idea, but I'm not sure if it's going to be any better. And this idea was to only store the timeline with the best resources in some dimension. Um, so here you would only check like the best 10 or whatever. The best 8 actually. You would take for every resource the one with the most robots and the one with the most resources. We could do this. Best timelines. So we would now store a lot of stuff. We have like max, resource, or is none. I mean, I guess we could give it. No, let's just say it's not. So we have resource ore, clay, silver, geode, and then the same for the max robot. And every time we're adding something to it, we check if we're now the top thing. Or maybe just at the very end for timeline. If timeline dot resources dot or is greater than timeline dot max or then dot resource dot or timeline dot max or equal. This is probably not going to work. So we got ore, clay, Silver and Geo. And then we got the same thing for and it's now 4, and here it's okay. And now we only need to write the method for timelines. I mean, also we should seed this and say timeline max resource 4 is equal to 0, and the same for so play silver geode, and the same goes for place geo or robot. And I'm just gonna go copy these because best timeline. Just return the comments. Yes. Okay. Let's see. It gets a little bit faster, but not a lot. I'm honestly surprised. I have no idea how to solve this day's task, day 19. It's beating me. Like, I had probably 5 or 6 different approaches, and all of them have failed. I'm just out of ideas. Like, I've been thinking about this for like a week now, longer. I still can't come up with a solution. You could turn it into a mathematical equation and say maximize um, maximize a function with a lot of constraints where you're only ever allowed to pick one thing to build, but like maybe it doesn't even matter what order you build things in or whatever you build, you just have to figure out like there's some multiplication you can do of all the cost requirements. Um, yeah, it's a tough one. It's a tough one for sure. Let's commit this. Nope. Hmm. What's really messing me up is the time component of it, because in order to get 12 obsidian, you can have 12 obsidian robots for 1 minute, or you can have one obsidian robot for 12 minutes, right? That's what makes this so difficult and hard to compute. It's crazy how these numbers are only varying by such small margins, but it's still causing such huge differences in what is possible to achieve, how many geodes. Yeah, I don't know. I think that's it. I think I'm gonna give up. Um, I've tried for probably 6 streams of about an hour each, maybe more. I think I just have to call it a write-off. I'm really surprised by the amount of people who've been able to solve this. There have been 15,000 people who have been able to solve it, which is arguably lower than all of them except for day 24. 24 was so simple. Man, am I missing something here? Am I missing something very obvious? Am I just using the wrong language? No, I don't think so. How is it possible that there's like thousands and millions of different timelines and they're not inferior, clearly inferior to any other one? That's what's bothering me. Like there's only 8 different parameters. How can you not be much worse across the board from at least one other thing? Yeah, I don't know. Maybe I'll revisit this eventually, but I think for this season, I gotta call it. This one did beat me. Might come back to the dynamic programming one, but yeah, not gonna be able to solve A19 for now. I'll see you next time. Have a happy new year. Oh, good evening and happy new year. I have had one more idea for how to approach day 19 in Advent of Code. It's the last day of the year. I would be pretty happy to finish the year by solving every single AOC task that's ever been out there. And I think there's a chance. Now, it will be New Year's in about 40 minutes in Europe. And I think maybe I'm gonna have to make some calls. But regardless, let's see how far we can get in those 40 minutes. So let's just quickly get all of this out of here. Activate our environment and then open everything in VS Code. So I think the big revelation I've had is not very a big revelation, but it's an idea. And it's that I will go back to my very first attempt at day 19, which is not this one, It's probably this one. Yes. So let's do a hard reset and then a soft reset and say uh, revert to first attempt. Um, I guess we don't really need this file anymore. So the big thing I've tried in the previous attempt was to save time by coming up with some shortcut to just look at a certain subset of orders. I think that's not going to work for the real answer. I think we can't cut any corners here, and we have to do the real thing. Now, my theory is that we only have to look into the future until whatever point in time where we're able to build the next geode. Does that make any sense? Now, I'm definitely going to rename Obsidian to be silver again because I really like this stuff. So just give me 1 second here to iron this out. I do think I had an error here somewhere. Well, these are all going to be changed to silver. These are all going to be changed to uppercase C. These are all going to be changed to uppercase O. And this is going to be changed to uppercase G. Okay, let's just read through this code one time to make sure we're not having any stupid mistakes, like accidentally setting the wrong variables. We got ore costs ore, clay costs ore, silver costs clay, gold costs ore, and gold costs silver. That seems about right. The string method is probably fine. Then we have the potential builds, or if resources or greater than equal to ore cost ore, and O not in ignore robots. Right. Um, do I still want to do the whole ignore technique? Well, actually, no. I think what I want to do is determine what we will build next. I think that's really helped me in the past to speed this up. So, how about we ignore all of this potential? I mean, first of all, let's commit this as a rename resource. I think that we don't need this method, so I will just delete it here. I think what we actually want is yeah, I mean, first of all, this is a mistake. There has to be oh no, it's not a mistake. Wait. Ore cost ore. Okay, so we got OCSG, we got ore, clay, silver, geo. We got ore minus ore, we got obsidian minus silver. Okay, let's just rename this to not be obsidian anymore, but instead be silver. Yes, thank you very much. We got ore minus ore, ore minus ore, ore minus ore, clay, ore minus ore, and silver minus. So that should be correct. I think we don't have any bugs. This one. Cool. Um, right. So I think we Should write a step method. We should write a futures method. Well, the step method is kind of the future method. Um, okay. Can build equals self blueprint can build. How does this method work? We do have a can build method, right? Where is it? We don't have a can build. Huh. Okay. So give me back the whole potential build thing because I want to return true or false. And this was part of the blueprint, right? So let's call it can build resources. We don't need a timeline, we need a robot. Um, if robot equals to O and then return true. Actually, no. If robot equals O, then we return or greater equals 4. Yeah, exactly. So let's do this 1,000 times fast. So we got clay. We return this or greater equal equals or if C equals to silver, then we return this and this. Perfect. And if we build gold, then we have the same thing except it's all the gold. Except for clay, we need silver. Yes. And it's not called gold, it's called geode. Yes. Geo cost silver. There it is. Okay. So, I mean, first of all, assert false. Let's throw an exception here. Unreachable. Um, we now have a method that determines if we can build the robot at hand. Cool. So a timeline always has a next robot. Um, Now the problem is that we need 3 different next robots, right? So at the start, um, we have robots that we can start with would be ore, clay, oops, and silver. Actually, that's not true. Can't even start with silver. We can only start with those. Yes. So timelines is we set this to be 0 by default. Yeah, that makes sense actually. Is R for R in robots. Now we got 2 starting timelines. Um, okay. Can build self resources, self next robot. This almost went very badly. Okay. I think we also want to have time, which starts at 0. Self time equals time. And we definitely want to store the global time somewhere. Let's say n equals 24. So what am I trying to do here? Hmm. If can build geode, then we return true and self, except we haven't added the resources yet. And also future equals self g, and then all of the future, and we return the future. Is there a difference to the amount of resources that we have? Yes. So let's just keep all of this in mind. Okay. If not, can build, return false, and self. Now, if we can build what we want to build, then we have an issue, right? Because now we need to determine all the new futures for what we could build next. So we start with an empty array. We say future equals self-build robot. Right? And then we return fascinating. We have to duplicate self here somehow. So first of all, false. We were not able to build a new geode robot. And then we have future copy with robot R or R in or play and solver. Now we just have to return this. Did we ever increase time by 1? I don't think we did. Let's do this here. Self, return timeline for self blueprint flawlessly. God, why is it so bad? Blueprint, resources, and then, oh, will be not a string, it's just a variable name. Okay. And then self time. Cool. So we always know what robot we want to build next. We have a break if we were able to build a geode. So we have new geode and new timelines underscore equals futures. If new geode, then new geode timelines. Append. I think it's actually plus equal to timeline underscore else new timelines plus equal underscore, right? Yes, I think that's correct. So now we check if we found a geode. If we did, we want to override all of the futures with the one that found a geode. So we say timelines equals new geode timelines 0 as an array. Except the thing that's still missing is sorting by resources. Like, sure, we were able to build a geode, but which one is best one of the ones that did find a geode? What if 2 potential timelines found the new geode? Which one is better? I think I'm just going to sort by the silver. So we can say sorted, and then key equals timeline to timeline resources silver, and then that's going to sort ascending. So what if I just add a minus, then it's going to be descending, so we're going to get the one with the most silver. Let's see what happens if we run this. Right, so we're trying to build something that can't be built, which namely is G. Yes, well, I should have put a G here. Okay, in futures, right? So this, of course, would be the next robot. Init is missing next robot. Okay. Where? Line 161. Right, so this is probably just self next robot, and this is also self time. So that went way too fast. I don't think that this is um, gonna give us the right result. So let's start by putting in the example blueprints. And for this, I'm quickly gonna do some editor magic here and turn all of these into spaces and remove a new line between them. So now we can do this, and we can also say test string equals empty string and then comment it out, but it's going to make it easier in the future. So now we want to print the maximum gold. So let's remove this for a moment and then say max of timeline resources geode for timeline in timeline. Right. So 107 and 85 seems like a bit much. So clearly we messed something up here. Um, I remember having this error like this bug before, but I don't really remember um, what caused it. So let's see. Um, we have, I think something here messed it up. If we're building ore, then ore costs ore. If we're building clay, then this one is exactly the mistake. So this should remove clay. We remove ore. No, actually, I'm wrong. Wait, what is the bug? I remember that we fixed this, but I don't remember how we fixed it. Okay. So the time is not too long. I know that that's not the mistake. We're starting with one robot. Um, let's check out the futures method, shall we? So we have if it can build a geode robot, then we build a geode robot, we add all the resources, we return true, and this one single future. Now we check if we can build the next robot that we want to build, which is whatever one we're choosing for the current strategy. We check if we can build we cannot build it, then we just add our resources. Oh. Well, first of all, this should be here. This is only going to give us more now, so we're even more wrong, which is amazing. Let's see. Why are the resources not getting properly deducted? Geo costs ore, geo costs silver. Well, one thing we can do is to just print the resources um, off the very first timeline, just as a sanity check. And of course, we don't have a print method here, so let's do this. No. This. and define it as a string method for self, and we say we return this ulines, random spaces, add this, oops, and then remove this. Just turn it format string, remove deleting space. We add a single letter identifier before so that we know what, and then print it. Yes, silver is way in the negatives. So something's wrong here. No, here. Uh-huh. Well, this is probably the reason. Yes, I remember having this bug that costs a lot of time to figure out. Okay. There was one more. If we're trying to build ore, check if we have ore cost ore. If we're trying to build clay, check if we have clay cost ore. We got silver cost ore, silver cost clay, ore, geo cost ore, and geo cost silver. Now, why do we have so many resources? I don't think any of our methods are mutating. I mean, maybe that's exactly the issue. Hmm. This might be the mistake that we're using the robot way too early, helping a little bit, but it's still wrong. I think this is the mistake. I think we shouldn't be doing mutating stuff. Yeah, we're increasing resources from other timelines. This is not. So let's get this out of here. Instead, return new resources with these parameters, and then we should be good. This method is not mutating, so we should say future resource equals, and same goes for this one. 9 is the right answer. 11 is not. So I mean, what happens if we flip this one upside down and we instead get the one with the least silver? Yeah. So this sorting is clearly imperfect, right? Because what we really want to have is the maximum amount of resources and not just the maximum amount of silver. What if we just do silver minus 4 or something. This is not gonna. So it's probably to do with the ratio here. So how about we just say we take, I mean, it's not just about the resources, about the robots as well, right? Can I sort by silver robots? No. Hmm. Can I find a heuristic between all the timelines, which is giving me the best option, or the one which was providing a geode the fastest? Um, I mean, maybe. What if we say this times blueprint geode cost silver, and then the same for ore. That's probably not gonna give us the right result. What if it just say timelines equals new G timelines? I mean, it's gonna make it slower, but we're always gonna get the right result now. It doesn't make it that much slower. Okay, perfect. I think we have a working system here. So this is max. Now I think we don't need I anymore, so we can just do this. And we can do for I blueprint in enumerated group blueprints. And then we say S equals 0, S plus equals M times I plus 1. And that should give me some result if we do print it at the end. Yeah, I think that's correct. So now let's see if we're able to solve this. I'm pretty confident in this approach. I think we're gonna have the right result now. It's gonna take a while to compute, not ages, less than a minute still, which is a good benchmark. And if I'm correct that this actually does produce a result, unfortunately, I think it's gonna take a lot of time because this time cutting is not possible if you never build any geodes. And as a matter of fact, I know that some of these things are really slow in building any geodes. So this time does add up. There's one thing we could do, which is figure out if there already have been any particular robots built. For example, if we never build any clay robots, then there's no reason to ever build a silver robot, right? Um, Man, I was a bit too optimistic about this one, huh? Yikes. Let's stop this process and see how fast we're getting here. Oops, no, AOCR. I mean, we're making some progress. We're looking for the number to reach 29 at some point. Now we're at 4. I do believe that removing silver until we've had a clay robot is beneficial. So next robots equals this if self robots if future robots clay, right? Because if we don't have clay, we can't build any else. It's just O and C. It will make it faster. I think we will still get the right result. The question is how much faster, and if we, whoops, no, don't solve it. Just run it. Ooh, that was close. Yeah, so we still get the right result. I don't think it made it a lot faster, but we can try. We can always try. Can we figure out if some of these are just impossible to? That's the how about we just print M whenever we have it so that we can start to see if some of them actually do produce 0 diodes. Yeah. So for some of them, the answer is just 0. And I wonder if we could cut those out earlier. So this one, for example, we need 10 obsidian. So we need to run this one for at least 10 minutes, or rather, wait, which one didn't produce anything? This one, right? Yeah, so it needs 20 clay. So if we are to do after 4, we have 1 clay robot. Then after one thing we could do would be to ignore all the ore requirements here and just do the clay requirements. And if we get to 0 result, then we know it's not gonna. The problem is that it's a very imprecise science and it would take a long time to change all this code to factor in both realities. Let's see. I want to wait until number 4 is complete here, which is blueprint 5 actually. Which might produce a geode, I don't know. I guess we could multiply this with this and see what we get out of it. So if 4 times 20 times 12 is above a certain limit, then we just know it's going to be 0. But that's a little tough. A tough call to make. Well, I was happy for a moment. Just one moment. I think we have to do more tricks together because like now there's going to be millions of different possibilities. Yeah, and we turn it with a 0. Like all this work just to get 0 as a result. So number 5 gave us 4 times 19 times 18, which is over 1,000. See, I have a feeling that we should be able to express timelines as sets. Okay, let's do this. I want to say timelines equals set of t tuple for t in timelines. Let's give it parentheses and we say def tuple self earn. Okay, let's call it 2. You got me. Parentheses, all the new lines get a comma, and we're off. And I've called it 2 tuple, no, just tuple. Naming convention here. And then we reverse this step by saying timelines equals timeline. Oh, we don't even have to give it the blueprint. But we do have to turn this into a tuple as well. And we do have to turn this into a tuple as well. So let's define 2 tuple here. And return self dot. Oh, I didn't add. We got 4 clay, silver, and geo, and the same is true for resource. Cool. Um, we did remove the blueprint from the tuple method here. Yes. So we are able to turn it into a set. We can do this. And then resources, resources for resources, robots next time. In timelines, robot time, robots, maybe. Let's see what we get if we run this. Looks like the right result to me. One thing we could also do for all the timelines that we're looking at is checking if one of them is completely inferior in all dimensions. If something has less resources and less robots, um, like for all the resources, then we know we don't have to keep track of it anymore. Now the question is, that's kind of hard to write, and I'm not even sure if it's gonna speed things up. So let's ignore that for now. We kind of have too many prints here. Let's remove some of them. So 33 is the answer we're looking for. We're getting it. Let's see if the whole tuple stuff speeded up the process. Not too sure about it. I think it did. It's still not fast, but it's faster. Or definitely took the longest before. So let's see. Yeah, no, we're getting there. We're getting some results. Man, this task is insane. Like even with all these ideas of how to cut it short, it's still taking ages to compute. Ages. And we have 30 different blueprints. 30. And we're just at part 1. This is never gonna work. Well, there is actually a tiny chance that we are able to I mean, first of all, no, never mind. I don't have anything to add to this. Let's just wait until it's complete and then finally submit part 1 and be happy about the fact that we got it at all. How much disk space do I have? 3. Enough to store all the bots, so I'm not too concerned. And finally, it's the non-correct answer. Are you fucking kidding me? We even had a higher answer before. How is this possible? Ah. I'm going completely crazy here. Well, what are we going to do about that? We're like at over 200 lines of code, and none of this stuff actually works. Ah, it's funny, isn't it? Well, I think I need to take a break. Thanks for joining me on this lovely adventure. And I'll be back shortly.